Let us start question number 9. ABCD is a trapezium in which AB parallel to DC. A, B, C, D. Data. ABCD is a trapezium AB parallel to DC. Okay? Diagonal intersect each other at point O. Diagonal AC and BD intersect each other at point O. At point O. Show that to prove AO upon BO, that is equals to CO upon BO. See here. Here we have only AB parallel to DC, right? Which does not form any triangle. So we suppose let EO is parallel to AB, okay, such that E meets at AD, means E intersect AD. EO is parallel to AB, so don't think about this for a while. In triangle DAB, EO parallel to AB, sides are in same proportion, DE upon AE, that is equals to DO upon OB. By Thales theorem, result number 1. Now, AB is parallel to DC given, and EO is parallel to AB. EO is parallel to AB, but AB is parallel to DC, so EO is also parallel to DC. EO parallel to DC. So in triangle ADC, inverted triangle ADC, in this triangle EO parallel to DC, so sides are in same proportion, AE upon DE AO upon OC equals to, by theorem, result number 2. Don't say result number 2, because here DE upon AE, here AE upon DE, so you have to inverse it. So first I inverse DE upon AE, OC upon AO by inverse. Now say result number 2. So DE upon AE, here also DE upon AE. So from 1 and 2, compare this. Left sides are equal, so right sides are also equals. DO upon OB equal to OC upon AO. See, we want to prove AO upon BO. Take this AO which is in division this side, it will be AO upon BO, and take DO this side. So it implies that what? Take AO this side and DO this side, interchange. AO upon OB, that is equals to OC upon DO, hence proved. Right? Now last question of this exercise, that is number 10, it is just like 9. Diagonals of a quadrilateral ABCD. Here I draw trapezium because I am going to prove trapezium. So I draw this. Diagonals of a quadrilateral ABCD intersect each other at point O. What is the data? Diagonals of quadrilateral ABCD intersect each other at point O such that AO upon BO, that is equals to CO upon DO. To prove ABCD is a trapezium. See now, if you want to prove that ABCD is a trapezium, then you need to prove that AB is parallel to DC. Here AB is parallel to DC given, and we prove AO upon BO, that is CO upon DO. Here this is given now, means this is the converse of 10 number is the converse of 9 number. See here, once again we suppose let EO is parallel to AB. Such that E meets AD. When if EO is parallel to AB, then in triangle DAB, EO is parallel to AB, I can write DE upon AE, that is equals to DO upon OB by theorem. See here I want DO here in the denominator, so I convert it. So take inverse proportion AE upon DE, that is equals to OB upon DO, taking inverse. This is your result number 1. Okay, now see, EO is parallel to AB, also given that AO upon BO, also AO upon BO, that is equals to CO upon DO given. Now check with this number 1. See, AO upon DO, BO, means here BO we have and DO we have, so I take what? Take BO this side and CO this side, alternate proportion, AO keep it as it is, take CO this side and DO this side, alternate, आगे पीछे, cross, call it result number 2. So from 1 and 2, compare, see right side, OB upon DO, here also BO and OB are same, OB upon DO, so these two are also equal. I can write AE upon DE equals to AO upon CO. Okay, check this in the diagram. AE upon DE, that is equal to AO upon CO. So in triangle ADC, EO parallel to DC according to converse of Thales theorem. Okay, now see, we take EO parallel to AB. Now EO is parallel to AB and we prove that EO is parallel to DC. Okay, EO is parallel to AB, that we suppose, and we prove that EO is parallel to DC. So from this two you can derive that AB is parallel to DC. One pair of opposite sides in a quadrilateral is parallel, AB parallel to DC. Therefore, ABCD is a trapezium. And sprout. Okay, this is your exercise 6.2. Write it. First, understand each and every sum again and then write. It is okay? That's it for exercise 6.2.